Hey y'all, welcome back. Today we're talking about derivatives of inverses. Number one says, let f of x be 1/4 x cubed plus x minus 1, where f of 2 is 3. Find the inverse of f, or rather the derivative of the inverse of f, when x is 3. So to answer these kinds of questions, sometimes it's easier to just rewrite the inverse of f as a different function. So I'm going to let the function g be kind of like a stand-in for the inverse of f. It kind of makes the notation work out a little nicer. So this is just an assignment I'm making. I'm saying let g be the inverse of f. You don't have to do this as I work this problem out. If you just replace all of the places where I'm writing g of x with f inverse of x, that is just fine. And I'll kind of show you, at least on this first one, how the work might look different if you don't make this statement. But I think it might make it a little bit easier. So now if I'm letting g be f inverse, we can sort of reinterpret this question as saying, okay, well, what's the derivative of g at when x is 3? So really we're going to evaluate that derivative when x is 3. And so because g is the inverse of f, we have our inverse derivative. Sorry about that little bell there. We've got the inverse derivative rule, which, let me write that out to the side over here. Okay, we have f inverse of x. If we're going to differentiate that, that's going to equal 1 over the derivative of f of, going to run out of space here, so let me move this over a little bit, of the inverse of f of x. Okay, now I'm using g of x as a stand-in for the inverse of f. So as I work this out, I'm not going to have f inverse here. I'm going to have g. Okay, so this formula only works if g is the inverse of f. So don't get too carried away with this derivative rule being written that way. Okay, let's get started. So first, we want to find, g prime of 3. Okay, so that's going to equal 1 over f prime of g of 3. Now, in order to answer this question, we're going to have to find two pieces of information. First, we're going to have to find what's g of 3. And that information is going to be given from this point right here. Okay, if 2 comma 3 is on f, then on f inverse, so maybe I'll write this over here. If 2 comma 3 is on f, that means that 3 comma 2 is on the inverse of f. Again, sorry for the bell. So 3 comma 2 is on the inverse of f. So what that means is that g of 3 is 2. Because remember, g we're letting be the inverse of f, whereas f of 2 is 3. Okay, so that's how we're going to evaluate g of 3. But then we need to evaluate the derivative of f at that number. So let's simplify at least that first part first. The g of 3 is going to be 2, and so we need to find f prime of 2. Now, f is given initially as 1/4 x cubed plus x minus 1. We can use the power rule to find f prime. 3 times 1/4 would be 3/4, so 3/4 x squared plus 1. And so if I want f prime of 2, I'm just going to substitute 2 in there and get 3/4 times 2 squared, which is 4, plus 1. So that's going to be 3 plus 1 is 4. Okay, so to finish this off, we're going to have the derivative of g at 3 is going to be 1 over 4, and that's our answer. Okay, that is going to equal the derivative of f inverse of x at, oops, not of x, sorry, at 3. Yeah, so that at that specific x value. And there's number 1. Let's take a look at number 2. Okay, we're given f. It says let f be 2x plus 1 quantity cubed, and let g be the inverse function of f. So in this case, same as the last one, g is the inverse of f. Given that f of 0 equals 1, okay, that means 0, 1 is on f. That means on the inverse, which is g, we have g of 1 is 0. It's saying, what's the value of g prime 1? Well, g prime 1 is going to equal 1 over f prime of gx. Okay, in this particular case, x is 1. So first, we're going to evaluate g of 1, which we get right here. G of 1 is 0. So we have g prime of 1 equals 1 over f prime of 0. And so we need to evaluate f prime of 0. To do that, we're going to find f prime, which, using chain rule, is going to be 3 times 2x plus 1 squared times the derivative of the inside, which would be 2. So if I want to evaluate that at 1, I'm going to have 3 times, let's see, 2 times 1 is 2, plus 1 is 3, so 3 squared times 2. So f prime of 1 is going to be 3 squared is 9 times 3 is 27 times 2 would be 54. Oh goodness. I'm not evaluating f. What am I doing here? I should be evaluating f prime of 0. Yeah, let's fix that. Sorry, y'all. F prime of 0. You probably noticed that before I did. Okay, so anyway, yeah, f prime of 0, we don't really care about f prime of 1. We're looking for f prime of 0. So plugging in 0 here is going to have 1 squared times 2. 1 squared is 1, times 3 is 3, so that's going to be 6. So g prime of 1 is going to be 1 over 6. So yeah, our answer here is D. Number 3, let f be a differentiable function such that f of 3 is 15, f of 6 is 3, f prime of 3 is negative 8, and f prime of 6 is negative 2. The function g is differentiable, and g is the inverse of f. So because it's the inverse of f, we can say that g of 15 is 3. We can say g of 3 is 6. And the derivatives, we're not so sure yet. We'll probably have to find that. So we want to find the derivative, or the instantaneous rate of change, of g, which is the inverse of f, at 3. So using our derivative rule here, it's 1 over f prime of g of 3. Okay, g of 3 can be evaluated with this piece of information. G of 3 is 6. So g prime 3 is going to be 1 over f prime of 6. F prime of 6 is given right here. So this one actually works out to be pretty easy. G prime of 3 is going to be 1 over negative 2. So our answer is A. Yeah, it wasn't so bad. The hardest part, I think, is just going to be like committing that derivative rule to memory. You know, you already know so many derivatives. Okay, well, we can wait for this to load, I suppose, here. Go ahead and pause the video until this thing loads. And there we go. It says the distance a particle is from 0 on a number line. So we're just kind of imagining a number line here, 0. And the distance that this particle, which is kind of like running around this number line, is given by this function. Okay, so the distance from 0 is given by this function that's in terms of t, which I suppose will stand for time. It's asking at what time is the particle stopped? Okay, so what we really want to know, when is the particle stopped, is when the velocity or the speed is 0. Okay, so we want to be looking for where the velocity is 0. And we can find where the velocity is 0 by finding the derivative of this position function. So this is kind of the thing you need to remember, is that if you've got some position function, which is really what this is, okay, so that we'll call it P of t, in this kind of case d, but whatever, the velocity is going to be equal to the derivative of that position function. Okay, maybe I'll just call it d because that's what it's called here. I don't want to confuse you too much. Okay, now this one doesn't ask for acceleration, but it's also good to know that the acceleration of a particle is the derivative of the velocity, which also happens to be the second derivative of that position. So you don't need to know that here, but in general, you should know the relationship between position, velocity, and acceleration. So the particle is going to be stopped when velocity is 0. So we need to find the derivative here. The derivative of this distance function is going to be 3t squared minus 18t plus 24. It's going to be stopped whenever this velocity is 0. So I'm going to set this equation equal to 0. And this will be pretty annoying to factor until you realize that you can divide everything by 3 and make this a little simpler. So t squared, what would that be? Minus 6t plus 8. So I could factor that to get t minus 4 and t minus 2, because negative 4 times negative 2 is 8, and negative 4 minus 2 is negative 6. Using the zero product property, we can set each one of these equal to 0, and we're going to get 2 times, 1 at 4 and 1 at 2. So these are the 2 times where the particle has stopped. Number 5 says use the table below to estimate f prime of 4. So notice 4 is not given, and actually no derivative values are given here. But what I want you to understand is that the average rate of change is simply the slope between these two values, and that's how we can estimate f prime 4. Like if you're imagining these are points on a graph, right? And we look at these 2 points in particular. We've got a point at 3, 4, and a point at 5, negative 2. So if I want to estimate what the slope is at 4, this is all the data I have. So really the only thing I can do is find the slope in between the 2 known values and just assume that the slope of 4 should be approximately the same. Okay, this is just to get an estimate. This is not saying, hey, this is for sure what the derivative is. We're just using the information we have to infer what the slope would be at 4. So the average rate of change is just simply going to be your normal slope formula. Okay, the change in f over the change in x. So the change in f is going to be from negative 2 to 4. The change in x is going to be from 5 to 3. So it would be negative 6 over 2, which would be negative 3. And we'll say that that is approximately the slope there. Okay, number 6, determine the slope of the tangent line of this graph at the point negative 1, negative 1. So it's going to be a little implicit differentiation practice. So let's go through the implicit differentiation here. We're going to have to use product rule here, and actually we're going to have to use product rule here as well. So derivative of x is just 1. So 1 times y to the 5th plus x times 5y to the 4th times a dy dx due to the chain rule. So all that is just coming from that first product. And now we'll have this second product times 5x to the 4th times y plus x to the 5th times dy dx. And hold up here. Actually, that should be a plus, not a times. Ooh, almost made a pretty big error there. Equals the derivative of 2, which is 0. So now I'm going to solve for my dy dx's. I'm going to keep all these, this one and this one, these 2 terms that have the dy dx, I'll leave at the front. I'm going to rewrite that first term a little bit as 5xy to the 4th dy dx And then that last term is x to the 5th dy dx. And I'm going to bring all those other terms, which really there's only two of them, the y to the 5th and the 5x to the 4th y, bring those to the right-hand side. So negative y to the 5th minus 5x 4th, 5 times x to the 4th times y. And then, so to isolate the dy dx, we're going to factor that out as a GCF, leaving me with 5x y to the 4th plus x to the 5th. And then to finally get my answer here, I'm going to divide both sides by all that stuff in parentheses. So I get dy dx is negative y to the 5th minus 5 x to the 4th y over 5x y to the 4th plus x to the 5th. Oh, goodness. Yeah, there we go. Okay, so this is the formula for the slope at any point on that implicit equation, or the graph of that implicit equation. So to find the slope at the point negative 1, negative 1, we're going to need to plug in negative 1 into x and negative 1 into y and simplify. So we've got negative 1 to the 5th minus 5 times negative 1 to the 4th times negative 1 all over 5 times negative 1 times negative 1 to the 4th plus negative 1 to the 5th. So take this one slow. There's a lot of negative 1s going on here. And to simplify this, what we want to consider is that any negative 1 that is being squared or raised to the 4th power or raised to any even power is going to end up being positive 1. Whereas if you raise negative 1 to an odd power like 1, 3, 5, 7, then it'll end up being negative 1. So this is going to equal this negative 1 to the 5th. That is an odd power. So negative 1 to the 5th would be negative 1. But we actually have negative 1, which ends up being positive 1. And then on that next term, if we take a quick look at the negative 1 to the 4th, that's going to be positive 1. So we have negative 5 times 1, which is still be negative 5, times negative 1 will be positive 5. So this will be 1 plus 5 over, in the denominator here, negative 1 to the 4th right here is going to be a positive 1. So you have 5 times negative 1 times positive 1 would be negative 5. Plus negative 1 to the 5th is going to be negative 1. So what we're going to have here is 6 over negative 6, which equals negative 1. All right, that is the slope of the line tangent to this implicitly defined equation at the point negative 1, negative 1. Number 7 says use the table to determine each of the following. If h is f of g of x squared, determine h prime of 1. Okay, if we want h prime of 1, we're going to have to find h prime first. So h prime is going to be f prime of g of x squared times the derivative of g, so g prime of x squared, times the derivative of x squared, which is 2x. So we got a nice little chain rule going on here. And so if I want to evaluate that at 1, I'm going to have f prime of g of 1 squared, which is just 1, times g prime of x squared, which again, 1 squared is 1, times 2 times 1, which is 2. So really the key numbers we're going to grab from that table are going to be g of 1 and g prime of 1. We can find g of 1 here is 4, and g prime of 1 is going to be negative 5 halves. So h prime of 1 is f prime of 4 times negative 5 halves times 2. Now, f prime of 4, I can find on the table, is 8/3. So h prime of 1 is going to be 8/3 times negative 5 halves times 2 is going to be negative 5. And so it looks like I'm going to get kind of a, it's not that bad, but negative 40 over 3. Okay, part B says if h is 1 divided by g, determine the derivative of h. So let's find the derivative of h first. Now, I could use quotient rule here, but it might be easier if I rewrite this. And gosh, I really hate doing this, especially on a day where we're talking a lot about inverses. But when you have 1 over g to the negative x, that's equivalent to saying g of x to the negative first power. Now, please note, we are not talking about an inverse here, okay? I really want to emphasize the fact that reciprocal notation and inverse notation are the same, but those two expressions are not the same. Okay, reciprocal is not the same as an inverse, but when you raise something to the negative first power, it's going to kind of look like I want to do an inverse, but we're not doing an inverse here. Okay, yeah, so we're not going to use our inverse rule. Don't think that is what we want to do here. What we really want to do is use the power and chain rule here for h prime. Okay, using the power rule, I'm going to bring down that negative 1, g of x to the power of negative 2. And then using the chain rule, we're going to multiply that by g prime x. So if I want to evaluate this at 2, find the instantaneous rate of change, we have negative 1 times g of 2 squared times g prime of 2. So let's go look at our table, and we're going to get g of 2 right here, it's 2, and g prime of 2 is negative 3/2. So h prime of 2 is negative 1 times g of 2. Let me scroll back up. G of 2 is 2. 2 squared is 4, so times 4, times the derivative of g at 2, and that's going to be negative 3/2. So if we want to simplify that, negative 1 times 4 is just going to be negative 4. Negative 4 times negative 3 is, positive 12 over 2, which is 6. Oh, wait, hang on. Oh, we're going to have to go back. We're going to have to go way back. Hold up here. Let's go back. I made a mistake here because this was a power of negative 2, not positive 2. Oh, goodness. Yeah, so let me correct that. This should be negative 2 here. Okay, so let's back it up. G of 2 was 2. So this is like 2 to the negative second power. 2 to the negative second power is equal to 1 over 2 squared, which is 1/4. So this should actually be 1/4. Now if I do that multiplication, I get negative 1 times 1/4 is negative 1/4 times 3/2. Just erase all this. Let's do that again. So negative 1 times negative 3 is going to be positive 3. And then 4 times 2 is 8. So I take it back. Our answer is actually going to be 3/8 here. Sorry about that. Yeah, should be 3/8. Letter C, determine the equation of the line normal. Remember, that we're talking about normal lines. It's going to be perpendicular to the tangent line at x equals 1. So we do want to write an equation. So we're going to need a point. We're going to need a slope. We are going to write our equation in the form y minus y1 equals m times x minus x1. But we'll have to find the slope of the tangent line first and then negate it, reciprocate it to get that perpendicular slope. So the point that we're going to be using is 1 comma something, and we can go back to f of x and evaluate it at x equals 1. Now this table's gotten a little messy, so let me erase all that. But f of 1 is 3. So we have a point, 1 comma 3. The slope is going to be the derivative of f at 1. So let's go back up and find f prime 1. It's going to be 2/3. Okay, now 2/3 is the actual slope here. But if I want the normal slope, that's the perpendicular slope, okay, which is going to be -3/2. So really the slope I want here is -3/2. So my equation is going to be y minus 3 equals -3/2 times x minus 1. And that's it for that one. Yeah, been a little while since we talked about normal slope. You know, I hope you're noticing on these past couple homeworks, we've had some various problems coming back, you know, from way back in Unit 1 and Unit 2, the limits and some of these other equations. But I think it's good to go back and review those before we get too far into the year. So hopefully you're practicing these, and you know, hopefully you remembered what normal meant. Let's see, number 8, our last question. We got another multiple choice, and it looks like we're going back to inverses here, which is a great way to end this homework off. We're trying to evaluate g prime of 8, where g is the inverse of f. So if that's the case, if it's the inverse of f, then this is going to equal 1 over f prime of g of 8. Okay, now before, on most of these problems up here, they gave us a point on f, right? And then we use that to find g. Here they don't give that to us. Okay, but what we really need is g of 8. So what we need to do is find the value that'll give us 8 here. So in other words, how do I want to put this? So g is the inverse, right? We're saying g of 8 equals something, right? So if that's true, then the inverse, the original function f of that something must equal 8, right? The x's and the y's get swapped. So to find that x value, okay, to find the value of g of 8, which is the x value, f of that value equals 8, we're going to set our equation equal to 8, and then we're going to have to solve for it. Yeah? Okay. So, yeah, we've got this. How are we going to solve this? Hang on a minute. You know, this is a cubic, and, you know, we have really not solved any cubics yet this year. But if we look at this problem a little closer, say, okay, we've got a sum that equals 8. And if you take a quick look at these coefficients, they're 3 and 5, which already have a sum of 8. So in order for this sum to be 8, the x cubed and the x both need to be 1. So like if x was 1, we'd have 3 times 1 plus 5 times 1, which would be 3 plus 5 equals 8. So this is a pretty unconventional approach to solving this, but I think it gets the job done, and we get a value that x is 1. Yeah, I don't think you'll be given one that's more complicated than that. You definitely have to be a little creative in trying to figure out what that x value is. But there it is. So that means that f of 1 is 8. Therefore, g of 8 is 1. So g prime of 8 is 1 over f prime of 1. Now we're going to have to calculate f prime of 1. Let me move this over. Or maybe I'll just leave there. Okay, so if f is 3x cubed plus 5x, then f prime, using the power rule, is going to be 9x squared plus 5. So f prime at 1 would be 9 times 1 is 9, plus 5 is 14. So yeah, f prime of 1 is 14, so g prime of 8 is going to be 1 over 14. I'm not going to lie to y'all. This is a challenging question. And I think the biggest challenge here is realizing that you're not going to be able to solve this equation with any kind of normal, properties of equality or anything like that. You really just kind of have to come up with it. And that's going to be pretty rare where you have to solve an equation like that, where it really boils down to kind of a guess and check kind of scenario. but that happened here. So on this old AP problem, that does come up. But I don't think we're going to see too many like that. So if this is the only problem that you're really struggling with, then I would say, hey, don't worry about it too much. This one's pretty hard. So yeah, I guess that's about it for tonight. Thanks for watching, and y'all have a great evening.